Chapter 1, Lesson 6, Video E. We're going to look at angle addition here, which is another postulate. And again, this is again laying the foundation for allowing us to write a mathematical expression, which then allows us to use the algebra to determine the solution. Alright, so here's the postulate. So let's take a look at some of the key points. And it's very similar to what we had before in segment addition, where if you have a large segment and you have a point that's in between two other points, then the two parts equal the whole part. Well, it's the same thing here. If point B is in the middle of, or in the interior of angle AOC, so if I'm looking at this diagram here and it says if B is in the middle of AOC, notice when they're talking about AOC, they're looking at this big angle here. So you're looking at this angle here, all right? If you have a point that's in that angle area, okay, which then would allow you to write or to draw this other line here, then what you've created is you've created two angles. Let me change color here. Two angles. This angle here, AOB, and this angle here, BOC, which together make up AOC. So just like angle addition, I can take angle AOB, the measure of that, add it to the measure of angle BOC, and that would give me the angle of AOC. It creates this mathematical expression that I could then use to determine the value of x. But again, this is the geometry, looking at the figure, recognizing the relationship, and then being able to write a mathematical expression based upon this angle addition postulate. Now, another thing that's kind of nice about that is if AOC is a straight angle, in other words, if you have any time you have a line and you have one or more angles that are adjacent, then this angle plus this angle are always going to equal this angle. And we already know what a straight angle equals. A straight angle is always equal to 180. So that would allow me to write this expression that AOB, which is from here to here, plus BOC, which is from here to here, well, if I take those together, they make this straight line, which I know is 180. So again, it allows me to write the mathematical expression, which I can then use to determine the solution or the value of the variable in the expression. But again, the geometry is what we're interested in. The geometry is the most important part. So if I wanted to break this down into some definitions, then the angle addition postulate, basically what we're doing is we're adding the measures of the angle. Similar to when we did segment addition, we added the lengths of segments. Okay, it can be two or more angles that add up to the big angle, or even the angle of 180. In this case, it's only two of them, but it could be more. Okay, it could be 3, 4, 5 angles. As long as they all add up together and they form a straight line, then you can use that they equal 180 degrees. So let's do an example. So here, what is the measure of angle TSW? Let's go ahead and identify that. So TSW is this angle from here to here. So what is the measure of that angle? So let's just call it X maybe. Alright, if RST, so RST is from here to here, and that one equals 50. And the measure of RSW, which is the measure of this one, this large angle, RSW, is equal to 125. Okay, so again, the temptation for some of you who are picking this up pretty quickly are going to be, okay, 125 minus 50, that equals 75, and you're going to have the solution before you've done any of the work. Whoops, it's right there. You're going to get this, but you've skipped steps 1, 2, and 3 of what this geometry course is all about. How do we know this is right? How did you arrive at that? Well, you say, well, I subtracted 125 from 150. Well, why did you subtract 150 from 125? Why would you do that? What postulate, theorem, or reason definition allows you to do that? See, that's the geometry. It's not about this answer. It's about how did you get there. So let's look at how we can get there. So as I look at this, anytime I see this figure, I want to think, oh, I know something about this figure. I know that because this ray is in between this large angle, I know that RST, which is this angle here, plus TSW, which is this angle here, that's going to equal this angle here. That's the geometry, that's understanding the relationship and then allowing me to write the mathematical expression because I know. And how do you know this is true? because of the angle addition postulate. Now that I have that, I can go ahead and substitute in the values of, let me do this. Actually, I'm going to do something here. I can solve this equation because I'm asked for TSW. I can subtract RST from each side, and I can get that the measure of TSW is equal to RSW minus RST. Now, for those of you who, again, who thought it simple, you said, well, that's what I did in my head. I subtracted 120. See, I was right. Well, again, your focus is on the wrong part. Your focus is on the solution, which is algebra. Our focus is in geometry, which is right here. So again, this is the important part of the lesson. This is part of it, but it's not the goal. This is the goal right here. Can you explain why? Okay, this is the why right here. So if you can't do this, if you're just going to give me this and say, well, I subtracted 50 from 125 until y, you say, well, because that's what it is, or whatever, it's because of this right here. All right, it's the angle addition postulate. That's geometry. That's what I need to know that you're able to do. So here's an example. Why don't you try this one on your own? Stop the video, do this one on your own, and then when you come back, we'll walk it through and show you exactly what you need to have, showing me the geometry as well as the algebra. Okay, so how'd you do? All right, so again, what I need to do is to look at the diagram and think about a definition or something that I know from a definition, postulate, or theorem that would allow me to write a mathematical expression without using any numbers or anything else, just using the shapes in the diagram. Well, again, I remember, oh, okay, this is a straight line here. So if I took this angle here, JFG, and I added it to this angle here, GFE, well, together they make that straight line there, so that's going to be 180. So I can go ahead and write the expression that angle GFE, it's this angle here, plus, GFJ, which is this angle here, plus EFG, together they equal 180. How do you know that? Because that's the angle addition postulate. And again, that's the geometry. If you skip this, then you're not getting the geometry. Okay, you've got to get the geometry. Now that I know this, I can go ahead and finish it off by substituting in, or actually I can solve this equation for GFJ first, so 180, subtracting EFG from both sides. I know what EFG is. It's 110, so I can put in 110, so I get the angle of GFJ is equal to 70, and that would be my answer. Again, if you don't have this, whoops, I'll get it here. If all you have is this, then you've skipped the geometry part of the course and you've jumped right here. And again, we start off with the ones that are simple because we know you can do them, and we want you to be able to know and feel confident about your answer being correct by walking it through step by step. So make sure you walk it through step by step. If you're missing this, you're not going to get full credit because that's the geometry part of the course. This, finding the solution, is not the focus of the course. This is right here, so make sure you're paying attention to that.